one number of 1 bits. So here we have given an input number and we have written the number of ones bit available in a number. So here you can see for 11 the number of bits would be 3. In the same way for 128 the number of ones would be 1. For this we must know how the bitwise operators works. So here you can see if we for AND operator, if both the values are 1, for that case we get the 1. In the same way for XOR operator, if we have different values, for that case we get a 1, and for OR operator if any of the value is 1 we get 1. So now let's try to solve this. Here you can see we have 3 ones available, but we have to count it somehow, right? For this we can utilize a count. Initially start with 0 and then we can simply return a count. To get this, what we can do, we have to utilize operator. So here you can see we have a 1. uh, what if we do an AND operator along with AND 1? If we do a number AND 1, here 1 and 1 will give us 1, right? And then what if we right shift uh, it, we delete a 1 from here, and 32-bit would become this, and again we can do 1 and 1. This give us 1. So previously we have a 1, we incremented it, so the count would become 2. In the third iteration, uh, our value would be this. 1 and 0 would give us 0, so the count remains same. In the third iteration, here you can see the 32-bit integer would be this, and same 1 and 1 give us 1, so the count would be 3. For better understanding, here you can see the initially 32-bit would be this. If we do a number bit, we can utilize a while operator over there and check if while number not equals to 0, keep getting the iteration, and we have to increment a count plus 1 if we do a n and 1. So for this, if we see 1 and 1, the this will give us the 1, and our count would become 1. And we do a right shift. Right shift means 0 is added in the front, and the last element will be pop out. In the second iteration, same, we have a 1. 1 and 1 will give us 1, so the count becomes 2. And then we do a right shift again. In the third iteration, 1 and 0 will give us 0, so count remains same. In the last iteration, 1 and 1 will give us 1, so the count becomes 3. And we came out of this loop because currently all elements are 0. So we came out of this and returned the count. So this is how we can, this is the simplest code. Let's try to code it and see if it's work or not. While number not equals to 0, we initially the value of count would be 0, that count equals to, and then we can do an count plus would be number and 1, and then we have to right shift. This is an unsigned bit, means initially it's always going to put a 0. For signed bit, the operator is this. We can go with the unsigned operator, so it will always push the 0 in the front. In the end, simply we can return a count. Let's try it. Okay, time limit exceeds. Oh, let count equals to 0. Okay, perfect. This is working fine. For space and time complexity, it would remain the same because you are not taking any extra space or time. Hopefully, you get it.